Hello, everyone. Thanks for joining us today. We're excited to be here today to talk through some case studies for supply chain, in particular focusing on how graph visualization and analytics can assist with managing processes with lots of pieces and lots of moving parts. This is Christian Miles speaking. I'm here on the left on the slide here. I help Cambridge Intelligence customers in North America get familiarized with graph visualization and applying our product key lines to a wealth of different domains. On the right, you see Dan Williams. You'll hear from Dan later. He keeps a firm hand on the tiller of Keyline's product management and keeps an eye on the roadmap for future releases. He has a wealth of experience across a number of different verticals, so it's great to be talking with him today. Here's a quick agenda. I'm halfway through the intros now. That's what we're doing right now, but I'm going to be also talking through the rest of the agenda right now. So we're focusing on supply chain today, so I'll be walking through why you would want to be visualizing supply chain as a graph. And then we'll be moving to a case study from Dan, focusing on manufacturing, and in particular the risk models associated with manufacturing. Then things will come back to me for an inventory monitoring use case, focusing on some liquor store data from here in Canada. And then we should have some time at the end for a Q&A, so please feel free to submit questions throughout the talk today. Everyone is muted, but we'll be happy to take those written questions at the end of the presentation. And just a reminder, this session is being recorded, so you should be able to share it with others afterwards. At Cambridge Intelligence, we help our customers visualize and analyze connected data. Now, connected data can take many forms. So whether it's the communication channels between terrorist cells, as shown here on this little visualization here, or whether it's entities involved in cybersecurity attacks and the inception of those attacks, or even tracking shipments as they travel between manufacturers and wholesalers in a supply chain. Our customers, we have over 200 customers worldwide, and they work in a number of different domains, including the ones I've just mentioned. Now, our product, Keylines, is a JavaScript library, and it helps uncover and highlight parts of data that may otherwise have been overlooked. Today, we're focusing on supply chain management, and here's a quote to kick off our discussion. The supply chain stuff is really tricky. So hopefully Dan and I will give you a flavor today of just how tricky managing supply chains can be. But who said this quote? None other than Elon Musk. Now, SpaceX and Tesla are just two high-profile examples of supply chains in action. So for electric vehicles and rockets. But really, all companies have some sort of supply chain, whether they are part of the supply chain themselves or they're taking advantage of the supply chain to get their goods to their customers. Now, in reality, there are a lot of different things we can mean when we refer to supply chain management. So here are just some of the pieces that could be considered. We don't have time today to dig into each of these, but Dan will drill into some of the items on the left, in particular for manufacturing and risk management. And I'll be focusing on logistics and inventory management here on the right side. And really, each of these different components have their own graph model to them. When we talk about graphs, when we talk about connected data, we're talking about entities that are connected inside of a supply chain or whatever your data set is. And those models can be shifted and adapted as per requirements for your company. But if we're thinking about how we would start to visualize that supply chain, regardless of which area that we're referring to, maybe it's nice to start off with a really, really basic picture of what we mean by supply chain and how to visualize it. So as I say, I wasn't joking. Here is a very basic picture. It's a very basic graph, so to speak, 2 nodes, 1 link. But here we are talking about a supply chain that is the movement and storage of raw intermediate materials from their raw state into customers' hands or consumers' hands. We have some oil drums representing kind of raw materials there on the left, but in reality, these raw materials could be educational knowledge. Really, they could be taking any sort of form. And in many ways, you could keep going left on this sort of diagram and you could keep coming across more and more raw materials that you're working with. Now, we can make this diagram a little bit more complicated when we consider how supply chains actually work. And actually, supply chains are bidirectional. You may not think this is quite obvious, but in reality, if you're delivering something to a customer, they are going to be in turn feeding things back down the supply chain. So whether that's money or information, just those can be considered as part of the supply chain. Or one real high-profile example is, say, liquidation or used goods that are being sent back or returned to customers. For one high-profile example, there's a company that sold $626 million worth of Amazon returns last year. So that reverse site supply chain, as it's called, can often be an important thing to consider. And as ever, the devil's in the details. So, these arrows really represent a whole host of different actual entities that are part of the supply chain. So whether it's the suppliers of the original source materials, the manufacturers that put pieces together, similar to the assembly line as well, or the actual end sort of final mile getting the product to the customer through distributors, wholesales, and the customer themselves. So if we're thinking about using key lines and using graph visualization, we're more likely to have a model that looks a little bit more like this. So here, this is a static screenshot of a key lines chart, but this is our first view of key lines today. And you can see that it's kind of broadly the same as the diagram I gave you just before. On the far left, we have suppliers. On the far right, we have customers. But now we start to get an idea of the model that underpins that supply chain. So a few things to note here. Firstly, we have two tiers of suppliers. So the first tier feed into the second tier. This is a bit of a dummy example. Really, we'd have hundreds or maybe thousands of different suppliers for large companies or large goods. In the middle there, we've used a combo to represent the fact that these two manufacturers are actually distinct. There are separate locations, but they're combined in some sort of way. So whether that's ownership by the parent company, or whether they are working together to produce two components of the same product. So for, say, planes, for example, the top manufacturer there could be assembling or manufacturing the fuselage, whereas the bottom could be manufacturing the wings. And then the distributor here, these are represented by the little truck icon there, or the lorry icon. So we can see that, using the distributors, we can disperse the product to the customers based on region or some other factor. And again, this is a bit of a basic example, because in reality, those distributors are probably quite complex and quite complicated in themselves as well. So without further ado, I'll hand you over to Dan, and he'll be talking through our first case study today.
Okay, thank you, Kristin. And hi, everyone. My name is Dan Williams. I'm the product manager for Keylines. And before I was here at Keylines, I spent many years in the engineering software for manufacturing industry. And one of the problems I was very preoccupied with was the problem of restricted substances in the supply chain. So I'm going to try and show you today a little bit about what the problem is, and give you a hint of how graph visualization and graph databases could help, particularly with avoiding risk in that situation. So when you think of restricted substances, you probably think of brightly labeled, foul-smelling, evil things that are very easy to spot. You can spot them a mile away. But the fact is that, in fact, there are lots and lots and lots of restricted substances, many of them very, very subtle indeed. There may be in everyday household plastics, like this pipe on the right. There could be all manner of different flame retardants or plasticizers that are used in the production of these things, and those chemicals themselves may be restricted or banned in some way. Sometimes these things become very high profile. So some years back, there was a scandal involving baby bottles. Baby bottles are made out of a plastic called polycarbonate. Polycarbonate is a plastic. You don't mine plastics out of the ground. You have to make them with recipes. And one of the ingredients in polycarbonate turned out to be nasty for the health. And so there was an interesting scandal, and people worried about what their baby bottles were made out of. Even if there was no trace of the initial chemical left in the final product, people can get very concerned about these things if they become a news story. And sometimes the restricted substances aren't in the product. They were involved in its manufacture in some other way. These brightly colored bike pedals here have been colored using an anodizing process. And that process involves the use of some chemicals. They never make it into the final product. They're just part of the process. But nonetheless, if that process is in your supply chain, then those chemicals are being bought by one of your suppliers. And so there can be things that you need to be aware of. And these three examples are a little bit simple, because at least I can show you them and tell you exactly which bit of it contains the nasty stuff. But if you're a manufacturer of a car, they say cars contain around 30,000 parts, then this gets very complicated indeed. If you can imagine a particular ingredient being used to make the plastic, which is used in one of the wires, which is used in a wiring harness which attaches the radio to your car, then you realize that you have a very big supply chain and a lot of difficult questions to figure out if any chemicals are in that supply chain. How many chemicals make up a car? I don't think anyone can tell you the answer to that. So it is a very, very difficult problem. Nonetheless, there are legislations out there which tell you that you've got to do something about this problem. One very popular legislation, popular is probably not the right word, but very prevalent one, influential one, is something called REACH. It's a European legislation, but because supply chains these days are global, it has global impact. And this legislation is constantly adding new substances. This is 2019. This was earlier this month, just a couple of weeks ago, 6 new substances were added to this list. And if you use any of those substances in your supply chain, there are obligations to report them. Your suppliers need to tell you if they use them. You need to tell your customers that you use them. So it's an ever-changing landscape of rather difficult reporting obligations. So what on earth can you do about it? And I'm going to try and show you why this could indeed be a graph problem. The first thing I did just for fun was I went to the European Chemicals Association website and downloaded the spreadsheet of that candidate list. There's about 200 substances on it. And I plumbed it into keylines just to see what it would look like. So here, each of these blue nodes represents a chemical. You've almost certainly never heard of most of these chemicals. They're linked to the reason that these chemicals are included in the legislation. So you can see that they are indeed pretty nasty things, and you can see the kinds of things that this legislation is protecting us from, which is all very good. And you get a bit of a feel, every one of these links has a timestamp associated with it. So if we were to look back in the early days of this legislation, zoom in, there weren't all of that many chemicals, and it might have looked like a tractable problem, but over the years, as we zoom out in time, you realize that more and more chemicals are getting added until you see the 200 that are being added today. Keylines gives us a nice fun way of visualizing the growth in this legislation over time. It might help us understand the landscape that we're faced with. That was just for fun though, but when you actually start applying this in principle, it gets pretty tough. So even if you were really well up to date with the legislation, you understood the chemicals, let's say you focused on this one and you figured out that this was used to make orange or yellow dyes, which could be used in your products. If you were a manufacturer of a product which was orange, how do you know if you've got that chemical somewhere in your supply chain? This is where the graph comes in. So this is a picture that shows a model we might use for modeling this problem as a graph. So a graph is nodes and links, and I can start anywhere in this picture, but we might start on the left with parts and products. This node links to itself, so parts can be linked to parts. The wire is in the harness is in the radio is in the car. Parts contain materials. Materials are used in parts. The parts are used in products. And those substances are often either used in the material or those substances are used in the processes, which in turn eventually make up the material. So the bottom left of this picture is what I've been talking about. On the top left of the picture, you have the supply chain itself, suppliers supplying these things, and the kind of picture that Christian showed, how the suppliers connect to each other. And then on the right, we've got legislation. So the legislation probably bans particular substances, and you might not even hear about it until you've read the news and discovered that the news has mentioned some nasty chemical or some scandal involving baby bottles, and then you suddenly need to figure out, is this substance in any of my products? And the graph gives you a clue how you might do that, because everything is connected here, and the power of graph databases and graph technology means that we can start to ask ourselves questions that traverse this graph. We can start saying, where is this material used in my product line, or what is the most risky supplier I have in my supply chain when I consider this new legislation. The first challenge you've got, though, of course, is to get the data, and this is not an easy thing, as you can well imagine. The color of these arrows shows you where this information probably resides. So the red line here is fairly easy. You might have a database of legislation, or like me, you went to the European Chemical Agency website and downloaded a spreadsheet. The blue lines here and the bottom left, the materials, companies are realizing they've got to figure this out. And the automotive industry has been doing this for many years. They have a system called IMDS, which basically captures all of this. If you're a supplier to the automotive industry, you declare what's in your parts. All of that information is shared up and down the supply chain. It's a really impressive database project, and that information is available. But if you're in another industry, you may not have anything like that, and you're going to have to find this stuff out. And because legislations like REACH are constantly adding new chemicals to the list, it's no use asking your suppliers, hey, do you contain cadmium chloride, they might give you an answer, but even if they say no, you don't know what else is in the product. So what people are increasingly trying to do is to get their suppliers to tell them everything. It's called the full material disclosure. They say, tell me everything that's in my product. And if you can figure that information out all the way down your supply chain, you've got a phenomenal amount of data that you can make use of. But no easy feat by any means. But let's explore what could happen when that data is collected together. And as I say, increasingly, manufacturing companies are collecting that information. It's in lots of different databases, but the power of graph visualization is once you've got it, you can build a graph, maybe transform that data into a graph format and start to analyze it. So let's have a look at how we might do that. I set up a very, very simple example, first of all, here, just to show you the kind of idea. So I'm starting off here. I basically set up a database with some simple substances and materials. I've built a kind of mini version of that picture. I've loaded it into a graph database. In my case, I used Neo4j, and I've written a very simple web front end which queries my database and lets me explore it using keylines. So this is keylines, and I'm telling it to do things like show chemicals as little warning signs and pull out some information from the database. So I'm looking at cadmium chloride here, and if I double click it, I send a query out to the database and say, what do we know about this material, this substance? And it's telling me this substance is on the REACH candidate list. It's one of these substances of high concern. And it's telling me that I use it in one of my company material specifications and in one of my company's material process specifications here. So I can carry on exploring. So as I drill down through the list, I can see that this particular material has lots of other chemicals in it and a process involved in its manufacture. And that process impacts other materials, and I can continue exploring around the database. And the key thing here is that I'm figuring out what is the impact of this particular substance on my particular manufacturing supply chain. And it starts to get overwhelming very quickly here. But if I pick that original material and ask for an impact analysis, we can use the graph structure to tell us that. So now we've hidden away anything that wasn't downstream of that particular material. So basically what this is telling me is ultimately if this material or this substance here were to be banned, then these are the parts in my supply chain that would be affected. It's affecting this process, this material, which is used in this assembly housing, which is used in this switch assembly. So I can straight away see how a particular substance. So if I'd read in the news about this substance being banned, I would be able to find out exactly how and why and how it impacts me. So that's the idea. Obviously, the example I've shown you here is very small and simple. So your next question is bound to be, how does this scale? We may talk more about that towards the end, but the key thing is when you have a huge amount of data in a graph, you want to make use of the power of the graph to ask questions about what is interesting in that graph. So there's probably no point in visualizing the whole thing on one screen. It would just be overwhelming and you wouldn't know what to focus on. But if you ask the right questions, you can let the graph tell you about the things of interest. So one very common thing that you do, and Keylines lets you do, is size or color your nodes by their importance. One measure of that importance might be how influential are they? How many nodes does this node connect to? And we use a method called eigenvector centrality sometimes. It's a fancy term, but what it basically means is rank nodes by how well connected they are. And the more well connected their connections are, and the more well connected those are, the more you score. So this could help you spot, what are the most important things to worry about? What materials do I depend on? What materials do I use a lot of? So if you're starting from scratch trying to solve this problem, I can focus on the important stuff first. However, if I use a lot of something like steel, it could be just because steel is a pretty, I can get steel from anywhere and it's not really a particularly high risk material. So there are other measures too. And the final picture I have here is of another measure called Betweenness. This is the same data set, but I'm sizing the nodes by Betweenness. And this is basically the nodes that are on the critical path. So if I took these nodes out of the network, what effect would that have on the network? And so this is kind of asking the question, for example, which of these substances or suppliers would have the biggest effect if they were to ceased trading, or the chemical got banned. Quite often what happens is a supplier says, oh, I can't use this chemical anymore, I'll switch it and use a different one, but they don't tell their customers they've changed it. They've changed their recipe, and downstream your product may not work anymore the way it used to work. Maybe your flame retardants has changed, and your car radio is suddenly more dangerous because it's more flammable because your supplier changed the recipe on you. So which are the suppliers that you depend on in the supply chain? Can I visualize them in a way that tells me where should I spend my effort and be more proactive about analyzing that risk? And to make it real, an example, this is a fairly old story now, but it's a really fascinating one. There was a fire in a small town in Germany some years back in a chemical plant, and that chemical, it turned out it made a chemical which was used as a precursor to a certain plastic that was very important to the car industry. This was one of the only plastics that was strong enough, but also resistant enough to automotive chemicals that it could be used in car engines. And when this factory burnt down, the supply of this plastic plummeted, and it was affected companies all over the world, the US and Japan and everywhere. So figuring out that you have a node of such importance as this particular factory in your supply chain would have saved people an awful lot of downtime and an awful lot of money. So finding these important nodes is a very, very valuable thing to do. Okay, that's just one small example. I'm going to hand back over to Christian now, who's going to talk about a very different example, the world of liquor store data and inventory management. So I'll hand back to you, Christian.
Great, thanks for that, Dan. Yeah, as you say, this is a case study that's near and dear to my heart. I'll be focusing on the sections highlighted on the right here, and these aren't necessarily the first thing you may think of when you hear supply chain, but they are critical components of the entire overall graph. In particular, we're referring to the management of stock and product as it's presented and delivered to customers or end users. And that is quite important. You could say it's one of the most important pieces because, you know, if there's no customer to be taking the goods or buying the goods, then what's the point in having a supply chain at all? And for this case study, I thought I'd introduce a couple of real-world examples of cases where inventory management has kind of gone wrong. This is one kind of close to me as well. In Canada, back in 2015, Target opened about 130 branches of stores in Canada, and for a litany of issues and problems, they actually had to shut all of them at a great loss. There's some great articles around about what actually happened in this situation, but a lot of them pinpoint issues around inventory management. In particular, the new system they brought in to manage all of the stock that was being sent to all the locations. One particular problem was that they actually didn't realize that half of the measurements of the stock as it was going to be put on the shelves were in inches and half of them were in centimeters or metric. So it actually meant that the actual store owners weren't able to put stock on shelves because it just literally wouldn't fit. Which is kind of a crazy thing to happen. A bit closer to Dan here is the fact that in the UK last year, a lot of KFCs shut down. So the chicken restaurants, I say restaurant, because of a chicken shortage. And it's quite funny that the transit of chickens to locations or the origin of that supply chain meant that, you know, actual real world stores shut down and people couldn't get their chicken. So my case study today will be focusing on the Liquor Control Board of Ontario. So I'm based here near Toronto in Canada. For those of you who aren't familiar with the LCBO, it controls the sale of alcohol in Canada. It's really the place you would go to get alcohol. It's the vast majority of sales are through the LCBO. There's a lot of stores around Ontario, and it's been kind of important, I guess, for nearly a century here. Now, all alcohol sales are regulated, and really the LCBO is definitely one of the largest purchaser or distributor of alcohol in the world. And thanks to an API put together by Carlson Nielsen near me, the LCBO API allows me to analyze and look in the data that underpins all of these stores and all of the supply chain that brings the product to the stores. The LCBO dataset is a treasure trove of information about all the drinks sold at the LCBO. It's definitely critical to have that data in the day-to-day running of the organization, in particular for the supply chain. And as we saw with the Target example, the data quality is important, and using graph visualization is one way to keep tabs on the attributes and the trends of the product being sold in stores. So here, I've actually taken that inventory data and I've put it in key lines, and I've focused on some of the attributes that I thought were particularly interesting. So in here in green, I have the actual products, and I've grouped those products by the category of product. So whether it's beer over here, ciders down here or wine over here. I've grouped those together as combos, so to speak, and these little numbers tell me the number of products inside each of these groupings of combos. Now, as you can see, as I've zoomed in, these purple nodes represent the tasting notes, and they're linking to different types of alcohol based on those tasting notes of the underlying product that is in each of these categories. Now, with keylines, I can zoom in and I can actually double click on some of these combos, and I can see the subcategories inside there. So I can see the actual ciders, and then I can go down all the way down and see the actual brand of ciders shown right there at the bottom of this combo here. So I have this nice nested grouping of those products. And then by selecting one of my favorite ciders here, let's say this one here, I can see links back to the different tasting notes. So I can spot other ciders or other types of alcohol that have the same tasting notes. And if I go for aromatic here, I can see that there are some other ciders with that same tasting note. And in fact, there's a whole bunch of wine that probably have that label as well. So this is a bit of a fun example, but it can start to give you some idea of spotting patterns in your data or your inventory that you may want to look at. For example, why are these two ciders, why are they not categorized as cider? Are they being lost somewhere in the supply chain? Same thing goes for inside of this wine category here. I see that actually I have some capitalization here that's a little odd. So I see that red wine is in caps here, and whereas it's stored mostly in capital case there, in title case. So this may be something I want to look into as well. Also at the top right here, I see there's some nodes here, and this seems a little weird. Why do these not have any tasting notes? But if I zoom in, I see that actually the LCBO does sell other products like bottles and things, product knowledge videos, etc. So it's perfectly reasonable that these aren't shown connected to anything in the chart. So that's the actual products being sold. What about getting these in front of customers in the stores? With keylines, we can take the location of the stores contained in the dataset, and we can put those, along with important statistics, directly onto a geospatial map. So those of you familiar with Toronto, this is a map of Toronto. And here we see most of the stores, as per the dataset, shown in their actual real-world locations around Toronto. You see that I put these little donuts around the nodes. These little donuts or pie charts represent the capacity of the store. So for example, this store here has in Avenue Road in St. Clair West. We see that it actually has about 50% capacity, which is maybe something I want to keep an eye on. Whereas this one has a much larger capacity that is mostly filled. And actually, the text on the node itself here, we have millions of dollars. So this is actually the amount of stock that is held at each of these locations. And you can see here that 318 is actually the largest number here on the chart. I could have resized the nodes to match that. But that shows us that Yonge and Summerhill is a very important LCBO, which it is. It's a hub for the rest of the LCBOs around Canada, or rather around Toronto. So you can see the links here represent some sort of connection between these locations. These are actually algorithmically generated shortest paths, so to speak, between these locations. They take into account the driving routes as well as some other hazards that may be between the locations. And so they're kind of a little bit of an abstract way of thinking about getting product between each of these locations. But this is the kind of the surface level of something that has been looked at with graph visualization for a very long time, and that is routing of transit between different locations. And with keylines, right here in the browser, I can run things called shortest path algorithms. So I can determine the shortest path between two of these nodes on the screen. And as ever, we like to use visual methods to highlight these in a particular way. So if I select this node, Eglinton and Lard, and I go down to this node here, we see that the shortest path has been drawn in gray there between those nodes. That's also taking into account the weighting of each of those links as well. And then we're using our ping functionality to keep animating that so we can see that quite clearly versus the rest of the chart. These sorts of visualizations are also useful for sort of what-if analysis. So, for example, we may want to see what would happen if a particular store went down. Maybe there was a weather event which meant that they couldn't be picking up product from one store to take to another. And so those are really helpful to be able to look in a visual manner so that we can drill down in a way that makes sense to us. And talking about drilling down, with keylines, we often find ourselves drilling down further and further into a particular use case. So my final thing I want to show you for this data set is actually looking at things more of a store level. Here we've taken a store plan or a floor plan of a particular store in Toronto, and we can see the stock as it's located on the floor of the particular store. I can zoom in and I can look at this in a little more clarity, so I can see the actual locations of the wine where it's from, for example, and I can look at it in comparison with the rest of the floor plan. Now, selecting a node as well means I can use our time bar at the bottom of the screen to look at the sales of that particular type of alcohol over time. So I can see that this has pretty much been up and down over the course of the history of this branch, this location. And I can also select another node here, and I can compare the two of them. So if I wanted to compare wine versus cider, for example, Ontario wines versus cider, then I could do that here quite easily with the comparison trend line of the time bar. Now, one thing you may be saying is this isn't really a graph, right? There are just nodes. There's no links, and I didn't really have any data that I could put on this view. But in reality, the LCBO likely has a lot of information regarding customers and the way in which they traverse stores, as well as maybe the planning around marketing for particular liquor items as they become more or less popular depending on the time of year. So one kind of stretch thing for this demo would be to put some sort of a heat map on the background, and then have some sort of visual way of saying I want to move this stock to a different location and match the customers that are coming into the store. So I'd like to just jump back to my slides to finish off today. As you saw, I've walked through some case studies there for the LCBO. I focused on the actual inventory at the beginning to looking at the actual tasting notes for each of these alcohols, and then showed how you could use keylines or other graph visualization methodologies to look at things in terms of routing between these different locations. And then finally had a nice example of a floor plan, so you can take the same data and look at it on a much smaller level on one of those actual stores in the world. And then we'll recall we went through some proactive compliance points with Dan. Really interesting presentation around those facts there. So thanks so much for your time today, and we're happy to take any questions that you might have. I'll check the Q&A now. It's been really nice to go through all these topics with you. We had one question submitted during the week actually, but please feel free to fill out the question box now. We'll be answering your questions now. The one question I had, and it maybe relates to what you said, Dan, was regarding if the question said about putting data from multiple different data sources on the same view or the same visualization. I'm not sure if you want to maybe talk to that a little bit more, Dan.
Yeah, absolutely. Certainly in the case I was talking about, that data will be all over the place, and it's very unlikely you'll have all of it in one place. Often there's a lot of projects these days to do ETL, so big, large-scale transformations and movement of data to solve various use cases. So I think it's a perfect use case for graph technology to build a graph database, to extract the data from the various databases where it is, put it into a graph database, and then do exactly the kind of thing I showed. If you want to, though, Keylines runs in the browser, and in many use cases for Keylines, you are genuinely, that data hasn't been put together until the moment it appears in the browser. We often use a technique called enrichment, where you visualize one database, and then I right-click on one of those chemicals and say, okay, now go out to a completely different database and get me a fact sheet about that chemical, so I can see its safety data sheet or its chemical formula or something like that. So yeah, there's different techniques for doing it. Not saying it's easy, because this data is in a lot of different places, but the technology is out there, and Keylines works very well with data from disparate sources.
Great, thanks. One other question I got during the week, and this is a really common question, I wasn't surprised by it, is just regarding how much of supply chain data can you put on the screen at once? We're lucky at Keylines we have a WebGL renderer, which means you can get an awful amount of data on the screen at once. It's not rare to see tens of thousands of nodes represented on the screen at once right here in the browser. But often it's the case that you don't really want to be putting that much data on the screen at once. Using some of the techniques I've shown today, like for example the combos, that original chart I showed you, you saw those many thousands of nodes underpinning the relatively small amount of nodes that were shown at the end. So combos are a great example of working with large volumes without having to show it all on the screen all at once. Other great examples are using the time bar filtering that Dan showed today, as well as some graph analysis algorithms like the shortest path, so you can just highlight things that are particularly interesting. There was a question just submitted, and please do keep submitting questions if you have them. Where is the place for graph analytics in risk management? That's an interesting one. I think Dan hopefully covered some of that today. I'm not sure if he has anything extra to add there, but I think the graph algorithms or the analytics that we've shown you with the betweenness of the eigenvector centrality, those are interesting techniques that aren't really that apparent if you're using sort of traditional dashboarding or some sort of analysis tools. Do you have anything else to add on that, Dan?
Yeah, that's right. I think there's two situations. There's the kind of reactive stuff where when a new chemical gets added or something, we want to say, how does that impact us? So I showed an example of that where having the data in a graph means I can just explore outwards from something and learn more about it. And then there's the proactive approach where you are using a graph on a large scale to say where is the most important stuff that I need to be spending my time on. And if your supply chain is made up of 30,000 parts and goodness knows how many chemicals, then you're going to need all the help you can get to figure out where you should be spending your time. So graph analytics can be fantastic at just telling you where the interesting stuff is in a sea of not so interesting stuff, if that makes sense.
Yeah, thanks, Dan. And you mentioned, Dan, that your demo used Neo4j. We have a question here regarding databases being used with keylines. And that is regarding whether keylines only works with Neo4j. This isn't the case. Keylines can work with pretty much any sort of data source. In fact, my demo today wasn't using a database at all. It was just using flat files on disks. I was just using JSON feeding into keylines. You could also query some sort of REST endpoint or GraphQL endpoint so you could get data into keylines. We have demos on our site for all of the popular graph databases, for example, OrientDB, ArangoDB, and so on and so forth. But really, we don't lock ourselves into any sort of particular database, nor do you have to be using a graph database. So a lot of our customers are using more traditional relational databases or even search indexes like Elasticsearch. There's another question here regarding getting a hold of the data and matching keyline page. I'm happy to share any of my demos or source data for your perusal yourself. Just drop us a line at the email address on the screen right now, and we'll be happy to help.
Yes, and likewise, the data I used was public data. It's on the European Chemical Agency website, so we can send that as well if anyone wants to get hold of it.
Great, thanks. And we have another question here. Where do you stand on network discovery, i.e. situations where you do not know which supply chain nodes can connect to other nodes for entire networks? That's an interesting question. It might be something we want to take offline. I'm not sure if you have anything to suggest on that, Dan.
Yeah, it's a good one. We do have customers doing network discovery, not in supply chain necessarily, just in IT, understanding IT networks and figuring that stuff out. Obviously, where we stand is at the visualization end. So, we're drawing the picture and helping you draw an intuitive picture. So either that network discovery has to happen first, and then you visualize the final results using keylines. Keylines could also help you understand what you don't know. We can quite effectively give visual cues like dotted lines or grayed out nodes or links in a diagram to help people understand what's known and what's not. In the little example I showed, I didn't have time to mention it, but the some of those materials I was showing you had little green check marks on them, which was illustrating that for those materials we had a full supplier disclosure, which meant we know everything that's in the material. So again, it's very, very important if you're an analyst in the environmental health and safety world to know what you don't know. So having visual cues that tell you this materials declaration is incomplete or this materials declaration is out of date, hasn't been renewed for 2 months is really important. So little visual cues to help people understand what you don't know is something we can do. Obviously, we can't help actually doing the discovery, being at the visualization end, but we've got a lot of things that can help with a product that does that kind of thing.
Great, thanks, Dan. And to reiterate a point earlier, we'll be sending out a link to the data along with the follow-up email for this webinar, and again, we'll be posting the recording as well. Any more questions? We're happy to take them. We have a few more minutes here, but otherwise, I think we'll be wrapping up. Thanks again for your time today, Dan, and thanks everyone for joining us. Hopefully, it's been an interesting session. Please feel free to drop us a line on the email shown on the page, info@cambridgeintelligence.com, and we'll be happy to answer any questions that might pop up later.
Yep, thank you very much.
So unless there's any more questions, we'll be logging off now.